morning, everybody. Welcome back to day 2. Today we're going to talk about scatterplots, creating linear regressions, and finish up with residuals. So taking a look at a scatterplot once again, it is a collection of points that's used to determine a relationship between paired data. Now, it doesn't tell you causal relationships. It doesn't tell you if something causes something else. It just tells you if something increases while the other variable was also going to increase, or if it's going to decrease as one increases, or if they're not related at all. So the coronavirus type thing is something you can take a look at as well. So as the number of cases increase, the number of people who are going into the hospital increase? Or, as the cases increase, does, the number of stars in the sky increase or something? Like there would be no relationship here, or there could be like an increase, but it doesn't mean that one causes the other one to happen, right? In the case of the hospitalizations, you could say that as they're increasing, okay, that does cause it, but it doesn't infer it if there is an increase, okay? So remember that the R value, okay, is referred to as our correlation coefficient. And when we run that number, it will tell us if there is a positive or a negative, I see IENT, that's pretty terrible, correlation, and whether or not it's strong or weak. So if the R value is close to 1, it's going to be strong, okay, positive. If it's close to a half, it's going to be a weak positive. Close to 0, there's going to be no correlation. Same thing. -1 is going to be a strong negative. -0.5 is going to be a weak negative. And then close to 0 again is no. Okay, so no, weak, and then strong. All right. Strong meaning that the numbers are very close to making a straight line. Okay. Weak might mean that they're more spread out, but there is an increase. All right. And then no, this would be no correlation, meaning they're all spread out and they're not really leaning towards a positive slope. Like we wouldn't say that this is very positive or negative, or if it was, you would say it's pretty weak. Okay, they're very far away from the line. They're not very close to it. All right. Also, how to create this scatter plot as well on your calculator. So what we're going to want to do is make a data and statistics page, like an Excel spreadsheet. We're going to label the first 2 columns. We're going to type our data in, and then we're going to go over and add, okay, our data and statistics page. We're going to pick our axes so that our points line up. And then we can analyze those numbers and pull out the regression stats and show the line of regression. We can show the correlation coefficient. We can do that separately without having to do this. So we're going to take a look at the first question here, number 1, okay? And we're going to ask ourselves a few questions. So for this set of data, number 1, which of these lines is appropriate? 2, is there a strong, or is it a positive, negative correlation? What type of correlation is it? And also, can we predict what the carbohydrates are going to be, or what the calories are going to be getting certain carbs? Okay, so let's take a look. So I already went ahead and entered the data into the calculator. Okay, we want to make sure after we enter in the data that you are not inside the last cell. So make sure you hit enter. Otherwise, it's not going to count as though 62 is there. So if you're still entering data in, it's not going to read the cell as having 62. It's going to think it's blank, okay, and give you an error. So the next thing we're going to do is we're going to hit Control Document to add a new page. From the lists and spreadsheets, which we just entered in our data, we want to go to Data and Statistics. We're going to go ahead and select the X variable for X, the Y variable for Y, and on the last page we had the label that at the top. So you may have called it, carbs and cal, or whatever you wanted to put up there. Now I can already see that these are starting to form a straight line, and it's increasing. So this is going to be a strong positive correlation. Okay, but we're going to go to Menu. We're going to go to Analyze, and we can go to Regression, and we can go to Show Linear. And we want to do MX plus B. And this is the linear regression for this graph. So this basically shows us the equation of that line as it goes through those points. Now, when we're on, we can also add in a regular calculator page. So Control Document again, Calculator, and we're going to do our statistics analysis. So we're going to go to Menu, Stats, Stat Calculations. We're going to go to Linear Regression. It's going to ask us what our lists are. So X is X, Y is Y. Saving the equation in F1. Everything else is going to stay the same. We're going to hit OK. And here is our equation. Okay, here's our R value. So you can see it's very close to 1. The residual is not coming up right now, and that's okay. We can talk about that a little bit later. But this R value tells us it's a strong positive correlation. Okay, now we can see the equation. So it would be the one that is choice 4. And if I wanted to predict any data, so what if I wanted to know if, let's say, what the calories are for 5 carbohydrates? Since we're plugging in for X, we're just going to do Y equals 14.1 times 5 plus 5.8. And then this will tell us the calories that are using that linear regression here. So 14.1 times 5 plus 5.8. And we get 76.3. And this is a good prediction because remember we talked about interpolation and extrapolation. If our number of calories is within, the number of carbs is within the data in the chart, then it is an accurate prediction. However, if we were to try to predict like 12, okay, and we would say 14.1 times 12, okay, plus 5.8, we're not going to get a very accurate prediction. 175 is not necessarily accurate because it's outside of our data. Okay, it's not going to be a good prediction. So this is something we want to be careful with when we're extrapolating data, that we're using our data for something that's outside of its limits of the numbers that are given. All right, on to the next page, residual plots. So residual plot is the difference from the observed value in scatterplot and the predicted value from the regression line, okay? So the difference between where the dot is versus where it's supposed to be based on the equation. That vertical distance is actually plotted on a graph. And if we get something that's very random, that means it's a good prediction, okay? If we get something that is, or it's a good linear prediction, okay, a linear equation is a good way to predict the line. And if we get a pattern like a U, okay, that means that a linear is not the best bet. You should choose something else. All right, so our first example here, okay, the 5 points below are on the graph here. So D1, D2, D3, D45. All right, student chose points at 1, 1 and 1, 5 to determine the best fit. They did not fall in the line, and here we go. So you can see the actual linear regression is right here. Okay, so the actual y value, right, for x equals 1, you can see right here is 1.5. The predicted value, so once again, rewinding, okay? To find the residual, state the actual y value from the graph of the given point. So the actual y value is this point right there, which is 2. The predicted y value is what you get from the line, what it's predicted to be, which is 1.5. And the difference, okay, is 0.5, and it's positive, okay? For x is equal to 2, you can see our actual value is 1, the predicted value is 2, and so the difference is -1. For 3, okay, you can see that the actual is 3.5, but the predicted from the line is, we'll say 2.8, okay? You could say 2.75, but we'll say 2.8, and this is the difference of 0.7, and it's positive. If you want to say 0.75 here, we would say 0.75 there. For x equals 4, okay, you can see the actual number is 3. The predicted value is 3.5, and so this is -0.5. And for 5, we see the actual one is 4.5. It looks like 4.25 for the actual line. And so this is a difference of 0.25 and positive. So our graph, if we graph these numbers, okay, would look like this, just a straight up residual. So it's like an XY chart, okay? I'm just going to use straight lines so we get a nice graph here for us. So all right, so here's our X, and apparently I'm still using straight lines. Here's our X, here's our Y value, okay? And then we would count out. So if you know our X values are at 1, 2, 3, 4, 5, we will want spaces. 1, 2, 3, 4, 5, and we vary between 0 and 1 and 0 and negative 1. So we'll do 0.5 and 1, negative 0.5, and negative 1. So the first graph we have is when X is 1, our actual residual is at 0.5. Okay, so when we're at 1, we're at 0.5. Okay, when we're at 2, we're at negative 1. When we're at 3, we're at 0.7, so it's about halfway up. When we're at 4, we're at negative 0.5. Sorry, 3. Oh, I just messed that one up. So 3 should be 0.7. 4 is at negative 0.5, and 5 is at 0.25. So somewhere around here. So you can see if we kept graphing points like this would keep bouncing up and down here. It would be a random. It's not making a curve like a U. So this linear regression is a good prediction. Okay, we would want to use this. Also, the closer these dots are to forming the x-axis, the stronger and better prediction it would be. Okay. So on our graph, we can create a residual plot, okay? So from here, we can go Menu, Analyze, we can go to Residuals, and we can say Show Residual Squares, okay? So this is the residual squares where they fall on the line. We normally did not do that. We went to Analyze, we went to Residuals, and we did Show Residual Plot. And so underneath, it gives you the plot, and it shows you exactly where those numbers are falling, okay? So for this graph specifically, this is what this looks like. And so since it's not forming a U, and it's kind of going all over the place, it's random, this is a good linear prediction, and you can see that by the line being used here, okay? That is it for today, guys. Hope you guys enjoy the rest of your day. Nothing on the next page. Oh, I lied. There is stuff on the next page. We're going to do this because we're crazy like that, right? So what I want you to do is pause it right now, okay? And see if you can come up with the equation, if you have a calculator. If not, you'll join me back here in a second, and we'll do the residual plot. All right, welcome back. So we typed in our data. So we're going to go ahead and we're going to enter in, to get our equation, a new document. Go to Calculator, Menu, Statistics, Stat Calculations. We're going to choose y equals mx plus b. Now I named our data to fit, so I named the hours studying, and y value was the score. That was based off of right here. Click enter for OK, and we get this lovely line right here. So it's y equals mx plus b. So here's m, and here's b, and it does say to round to the nearest hundredth. So now we know what to round to. So we're going to do y equals m hundredth is 6.32, and the next number after the 2 is a 1, so it stays a 2, so 6.32x, okay? And then the y value is positive, it's 22.42, and the next one's an 8, so it's going to make it a 3, so plus 22.43. And there's our equation, okay? Is it a strong like, is it a positive regression, negative regression? We would want to take a look at the R value. We see that it's 0.5, so it's very close to 1, so it's a strong positive regression. Okay, the residual is not showing up because there's a lot of numbers, so it's not going to give those to us. All right, we're going to go ahead and make our scatter plot now. So we're going to go ahead and hit Control, Document. I'm going to go to List Data and Statistics. We're going to choose our X value, which is the hours, the Y value, which was the score. You can see there's our regression, not as tight forming a line as last time. So that's why the R value is a little bit lower. We'll show that regression. So menu, analyze, regression, and we're going to go show linear. Notice that I can't choose residuals until I actually make the linear regression line. Now that this equation is in here and the line is drawn, now I can actually make the residuals, okay? So we'll do show plot, and there we go, okay? So is this a good line? You say, yeah, it's kind of random. It's all over the place. It's not making a perfect U here. So it is. And we now want to create our residual based off of the numbers. I got to make this a little bit smaller just so we can use it here for me. And we're going to go ahead and make the plot. So at 1, we're at 1.3. So 1 just above 1. Okay. At 2, we're at 1.9. So almost at 2. Okay, 3 is at negative 6.4, just in between negative 6 and negative 7. 4 is at negative 0.7. 5 is at 2.0. Okay, 6, the residual is 6.6. So that's going to be up here. And at 7, it's negative 4.7. So almost at negative 5. And there is our residual. Okay, so we want to then state, all right, whether the equation is a good fit for the data and justify your answer. We're going to say yes. Okay, the linear equation, say above, is a good fit. Since the residuals graph, and we can say two things. Either is a random group, or we can say has no pattern. Okay, if there is a pattern, we would say it's not here. There isn't a pattern to it, so we would say that it is. Okay, and you can see there's our graph here. Okay, all right. Now that's it for today, guys. Enjoy the rest of your day. See you tomorrow.